Okay, the next place we're going to jump into is in section 7.2. We're going to get into what we call sample proportions. Continues from the idea of a sampling distribution again, which we looked at in the last section. Again, remember, sampling distribution is all samples, actually I should slide in all possible samples of some size from the same population. Okay, so for instance, we would say that if I had a class and I wanted to take and create a sampling distribution for their test scores, okay, of size 5. So what it would be again is that I would have every possible group of 5 students and possibly find their average score on that test and then create a distribution from that. We're going to look specifically here at proportion. So now we're going to talk about proportion of my sample that fits some characteristic. Okay, what proportion of students have a GPA greater than 3.5? Okay, a couple things again, reminders about proportions. Again, we want to talk about them as decimals. And I know sometimes we'll see them as percents. Okay, and then notation-wise again, p hat. Okay, make sure we put that with my sample proportion. If I just use p again, that'll be my population proportion. Okay, so understand the difference between those when we run into them in our reading. Okay, this is the biggest thing that you have to have out of this section. Okay, if I were to choose a simple random sample of some size n from a population size big N, okay, so little n is sample size, big N is population size. And with my population size, big N, I may not know it. And we'll talk about that a little bit in terms of, we kind of have an idea of how large it could be. Okay, and then again, population size N, sample proportion P. Okay, normally we will not know that. For the time being, a lot of times they'll tell you what it may be, and we'll just run with that. And then P hat is going to be your sample proportion of successes. We'll talk about that in a little bit. So what they're saying here now, number one, my mean is going to be, or my mean for my sampling distribution of p hat. So what this is saying is mu is the mean of all my p hats, of all my sample proportions. So I'm going to take and put together that distribution like I was saying. And then mu sub p is going to be the mean of that, the middle of that. And that's going to be equal to what my population proportion is. Okay. Second thing, we're going to want to find my standard deviation for this sampling distribution as well. Okay, so sigma again is your standard deviation again for all p hats. So for all my sample proportions is given by this. As long as, and this 10% condition is going to be very common for us as we go forward here. Okay, and I redo it this way. They say little n, so my sample proportion is less than 1/10 my population proportion. I like to go 10 times my sample. It's going to be less than or equal to my population. Okay, because again, if I don't know my population size, how am I going to take 1/10 of it? So I think it's just easier to look at that. Now, truly what we should do is this first, then we'll find my standard deviation. So there's no reason to go find your standard deviation then to find out that you can't because the 10% condition did not hold. The third thing, and this is the big one, this is what's going to allow us to find some probabilities. Okay? As my sample size increases, my sampling distribution of all my p hats becomes approximately normal. Okay? If the normal condition is satisfied. Okay? So same idea. I should do this first, and then I'll come in and say, hey, I can do the normal calculation. So n times p, and your sample size. P is your proportion that fits a characteristic. So it's almost like your proportion of successes. Okay, so what this really kind of is that my number of successes is greater than 10. N times 1 minus p then is your number of failures is greater than or equal to 10. Okay. How many successes do I expect? How many failures do I expect? And that's where we come in with that idea. Okay, so just a quick one, if you have our book, there is a situation where the proportion of internet users that watch videos is 0.75. They took a sample of 1,000. Okay, and so they asked you to find a couple things. Your mean. Mean is always easy. Your mean is equal to your population proportion. So we're talking mean of our sampling distribution. Okay. Work on doing notation. Okay. Standard deviation then. Number one, check your 10% condition. Okay, so how I deal with my 10% condition here is I would say 10 times my sample, 10 times 1,000. Is that less than or equal to my population? I'm going to say yes, because my population is internet users, and I'm pretty sure that there's more than 10,000 of those, which then allows me to go in and calculate my standard deviation. So again, P, 0.75, 1 minus it, divided by 1,000 square root, and get my standard deviation. Third question asks, describe your distribution. Okay, and describe your distribution, again, that's your sucks idea. And so the first thing again is looking at shape. Okay, so what we got to think about here is I'm trying to get to the idea that it's approximately normal. So again, what I need to do is check n times p, n times 1 minus p. Okay, so I expect out of my 1,000, 750 are watching the videos, 250 are not, which are both greater than 10, therefore normal. With my normal distribution again, my mean is 0.75, my standard deviation 0.0137. Okay. Now, if I change my sample size, and one of the things we've talked about many times is how if I increase my sample size, I shrink my spread. Okay. So I'm increasing it to 9,000, that's going to decrease my spread. Nothing else is going to change. Okay. But I have to recalculate my standard deviation out, where again, the only thing that changes is my sample size. All right, so using our normal approximation, I'm just going to go through this one quickly because it reviews our 4-step process. But we got an organization, 1,500 first-year college students, how far away their home is. Okay, 35%. That's your population proportion. Say they live within 50 miles of home, or their school is within 50 miles of home. What's the probability of a random sample of 1,500, so again, there's your n, will give a result within 2 percentage points. So 2 percentage points below, 2 percentage points above. Now, 4-step plan, again, number one we want to state, and that's really just restating the question we're trying to answer. We want to find the probability sample proportion falls between 0.33 and 0.37. Notation-wise, we're talking about my sample proportion, so p hat. What's the probability that that falls somewhere between 0.33 and 0.37? Okay, so that's what I'm trying to answer here. Step number 2, let's get into my plan. What am I going to do? Okay, well, here's the information we have. Simple random sample of 1,500, population proportion of 0.35, attend college within 50 miles of home. So we're just listing the information that we know. Okay, so now what I'm going to go into is I'm going to think about the situation here, and I'm looking at, I have this population proportion, maybe I can use the sample proportions idea. So in that case, if I'm going to think about my sample proportions, again, the mean is equal to my population proportion. Now, they calculate standard deviation. What I need to do again first is make sure that 10% condition holds, which it does. Because I'm going to make the assumption that there's more than 15,000 first-year college students. Now, the other thing that we've been getting kind of lazy with sometimes is we need to draw some type of a diagram. Okay. There's 0.35. That's the mean of my sampling distribution. I'm saying this is my sampling distribution right here. Okay. What's the probability we fall between 0.33 and 0.37? So we'll find that area. Okay. Which means the next thing I want to try and think about in my do process, where it's my third step, is actually doing some calculations, is I can maybe use a normal distribution. Can I show that it's a normal distribution? Yes. Successes is 525, failures 975, therefore both greater than or equal to 10, I can use a normal distribution. So I can either go and calculate using my z-scores, which if you need to look at this a little closer again, you can pause this. And they come up with your value here, 0.8968. Don't forget also, we can use a normal cumulative distribution function. Minimum value, maximum value, mean, standard deviation. But again, remember, if you're going to do that, you need to explain what each one of those numbers represents. Now, it's not going to be exactly the 0.8968 that they got, but it's going to be very close. Okay? You just go round off of what the calculator's doing. So, finally, the last thing we do in our 4-step plan, again, is our conclusion. Okay, 0.8968, so about 90%. Now notice when we start dealing with conclusions and describing what's going on here, we change it back to a percent. Easier for people to understand when you say 90% rather than 0.8968. Okay, so about 90% of all simple random samples of size 1500. You've got to talk about that because we're describing that sampling distribution. Okay, I would expect that 90% of all my samples of size 1500 will give a result within 2 percentage points of my population parameter. Okay. You can go 90% of those simple random samples of size 1500 will be between 33 and 37%. All right, that's it.